Hello, my name is Outage. I'm product manager in Nokia in cloud-band infrastructure software. I apologize for my voice. I'm a bit sick, trying to recover. Together with me, Moshe Lavi, product manager in CBAM, cloud-band application manager, and Undrosh Urban, senior software developer, also from CBAM. We will talk today about the end-to-end failure detection, root cause analysis, and auto-healing. So I will start the session with reviewing some of server failures and how they impact resources and applications. Then Undrosh will start the demo, part one of the demo. I will then talk about Vitrage. Vitrage is an OpenStack project for root cause analysis, and it's a core component in this solution. And next, Moshe will present the VNFM and the second part of the demo. So let's start with talking about failures in the NFVI and the Vim layer. So failures can be in any layer. It could be also in the application layer. It could be in the network service layer. But I choose to talk about the NFVI Vim layer because one main reason. Because these failures are critical and are affecting the layer above. So I try to separate the error into a few categories. And let's review it and see what are the types of the errors and which action we need to take from the NFVI Vim layer. So first, the planned maintenance. Some of you may say this is not an error. So you're right, I called it a planned error. The actions are very similar, but we need to take some actions in order to enable the service to keep running. So an example of a use case for this planned maintenance could be either if we want to do some changes in the software, like upgrading or software patching, or to replace some component in the hardware. In some cases, we don't need to replace the entire server, but just a component like a disk that we want to replace. Then we need to take a maintenance window to do this software or hardware replacement and keep going. But we need to take some action. We cannot just do it without notifying or without understanding that we are impacting resources that application, for example, are using. So we need to migrate the relevant VMs, and then we can do the graceful shutdown. The next type is unplanned server reboot. In this use case, we have a outage of the server, but it's a temporary outage. So after a short while, the server will recover and back to normal behavior. But it's not just to check the status of the server that now the server is OK. We need also to go and check what is the status of the VM. Are all the VMs are now running again, or maybe some of them in error? Maybe we need to take some action to recover those VM, to notify the application, and so on. Next type is the unplanned server outage. And I divided into two. One is use cases where the hardware can be recoverable by taking some operation. It will take time, but it's recoverable. And the other type is when it's not recoverable. So for the first one, The example are disk failure, power supply failure, NIC failure, and it could be like the tenant NIC failure when the workflow traffic is affected, or the infra NIC failure where the workflow traffic is not affected. In all those cases, the server is out of service for a time. It could be minutes, it could be more. It takes a time, and the recovery is taking some time and action that we need to do. So the action we need to do is first to disable scheduling new VMs to this server. Then we need to maybe do some auto-evacuation procedure, calling Nova to do that, and to make sure that the VMs can run on LC servers. Then we take the operation and make the server back to normal procedure. The last type, as I said, is the unrecoverable hardware failure. An example is like a motherboard failure. We need to scale in to remove the entire server. And again, we need first to make sure the VMs can run on a different host, available host, and then taking the action to scale in and to remove this server. So if I'm looking on the end-to-end flow, and this is an example of host NIC failure, but it's true for any kind of failure, we have the layers. We have the NFVI, the Vim layer. On top of it, we have the application layer. On top of it, we have the network service layer. And a failure in the hardware, like a host NIC failure, is affecting the host, is also affecting the VM that running on this host, and then it's affecting the application. So we need to make sure that this failure has been triggered and raised to all the owners of those resources. So the NIC failure trigger alarms that impacted the host and the VMs. We should notify the VNFM, the application manager. We should take the action for the application, and so on also for the network service. In Nokia, we have all these three products, one for each layer, and we can provide this end-to-end assurance solution. In this session, we will focus on the part for the NFVI and the VNF Manager. We are not having the network service section here. So this is a time to invite Undrash to start the demo.
Hello. I would like to show you a short demo about monitoring functionality. Okay. What you can see, this is the, going back. Okay. This is the login screen of Cloud-Band Application Manager. This is the Nokia Virtual Network Function Manager. Later on, my colleague Moshe will discuss more about the VNF Manager functionality. So now let's move on the demo. We log in to the VNF Manager, and soon you can see the main page of the VNF Manager. You can see there are several tabs for different functionalities. For instance, on the Catalog tab, if we are moving, you can see the list of VNF packages. VNF package is a set of definition which describes the VNF, and such as cloud resource structure and the service which is expected to run on. You can see there are several versions of VNF packages there. And if we are going back to the VNF list, you can see the VNFs which are managed by the VNF Manager. If we click on the VNF, you can see a generic, soon you can see a generic information about the VNF, such as the name of the VNF, the version of the VNF package it was created from, and also you can see down the instantiation state is instantiated. That exactly means the cloud resources are deployed on cloud and the services are up and running. So, and we also have an instantiated VNF info tab where you can see further details about the instantiated VNF. Besides these, we have the operations tab where you can see the list of the operations which can be performed on the VNF. You can see there's instance scale, and especially the heal operation will be very important in our second demo scenario. So this is the VNFM side. But let's take a look at on the OpenStack side. Here, what you can see is the Horizon UI, and actually this is the entity graph of the Vitrage. Vitrage is an OpenStack is an open source project, which is available also in the Nokia Cloud Infrastructure software. On this graph, you can see the related resources. The resource is the vertices, and the connection between the resources are the edges. You can see we have several compute hosts. We have several hosts, and on one of the hosts we have two VMs, and one of them, which is the VM of the VNF. This VM is a part of a heat stack, which is also on the graph, and also the VNF itself is visible on this graph. There is also another, going back a bit, there is also another instance, another virtual machine, which is a standalone virtual machine. And it's important to mention there are two network interfaces which are related to the host. And also, if you click on the resources, you can in this tab you can see further information about the resources. All of the resources are marked with blue, which means they are in healthy state. And besides these, we have a topology view as well. Topology view is a hierarchical view. Actually, in the middle of the circle, there is that OpenStack cluster, then the zone, then the host, and at the end, there are the instances, I mean the virtual machines, which are located on that host. Everything is marked as green because the resource state is healthy. And if you click on those resources, the selected resource will go to the middle. And on the left side, you can see further information, and you can see there's no active alarms related to the resource. Yeah, and besides that, we also have another view, which is alarms view, where the alarm will be listed. And actually, there's no alarm currently because we have no fault situation. So let's trigger some fault situation. Triggering a fault situation will bring down the two network interfaces, which was mentioned earlier when I introduced the entity graph. And so what will happen? The VNF Manager will recognize that the VNF is not reachable, and it will report Vitrage, my VNF is not reachable. So there is some problem. And if you go to the entity graph, you will be able to see there are alarms appearing related to the resources. And what you can see, some of the resources change color. For instance, the host is red because it's not available. You see these network interfaces are not working, and you can see alarms also related the VNF, yep. And also related the heat stack, and also related the instance, the virtual machine itself. And besides these, there is the topology view, which you can see soon, where you will also, it will also change to red, because the host is not available. And the virtual machines are also not available on the host. If you click, then you can see in the info tab, you can see there are alarms related to the resources. And of course, these alarms not only shown here, but it is only also shown in the Vitrage, I mean the alarm list. And it is really important to mention, as you can see, there are several alarms, but only 2 of them are reported by Zabbix. So what is Zabbix? Zabbix is also an open source component, which is responsible for monitoring the resources. And Zabbix monitors the resources. Zabbix reported that the 2 network interfaces are down, and the Vitrage calculates the further alarms and also calculates root cause analysis. So if we filter on the Zabbix alarms, you can see only 2 of them. You can open each of them, and you can see the RCA icon at the end. This is the root cause analysis. And now you can see the root cause analysis, which was done by Vitrage. You can see there is that network interface error, which is because we bring down the network interface. And then it caused bridge down error. And then it caused no network connectivity on the host. And you can see there are 2 alarms related to the instances, because there were 2 instances related on the host. And one of them was a standalone resource, virtual machine, and the other was the virtual machine of the VNF. And as this is the virtual machine of the VNF, there is a corresponding heat stack, which has also an alarm. And there is the VNF, which is also in suboptimal state. So you can see the relation between the errors. So thank you. That was the first demo scenario. Later on, Moshe will show you the second demo scenario, which will describe you how we close the loop. And now Ohad will describe you the Vitrage in more details. Thank you.
Can you switch back? Okay, thank you. Yes. So I will switch back. Okay, thank you. So before Moshe will show you how we are doing the auto-healing of this scenario, I want to talk a few minutes about Vitrage. So as you saw, Vitrage is a core project in this solution. Vitrage is an official OpenStack project for root cause analysis. It's initiated and led by Nokia, but we have a lot of contributors from other companies. And it's since a Newton release official project. So Vitrage main function are raising the deduce alarms and states. As Undras presented, there are 2 alarms in the demo that we got directly from the monitoring tool. Those alarms are from the Zabbix, and all the rest of the alarms are alarming that deduced by Vitrage and raised on the affected resources. The second function is the root cause analysis, to understand the relationship between the alarms, not just a flat list of alarms, but knowing or understanding the relationship between them. And the last one is to provide a view, a holistic view of the entire system, the correlation between the different layers. The architecture highlights, I will move to the high-level architecture, and we will talk about the main architecture highlights. So this is the high-level architecture of Vitrage. The first one I want to talk is on the left side are the data sources. And you can see these are the data sources available today in Vitrage, and the list is quite long. And we have here a few types of data sources. One type is OpenStack project, like the Nova, the Cinder, the Neutron. Another type is the monitoring tools like Zabbix, Nagios, CollectD. We have also Kubernetes and Prometheus as data sources. And the last type is static data sources, like configuring the static file for the switch configuration. So we support all of these data sources, and what the beautiful is that it's extendable. It's very easy to add a new data source. It actually takes about 2 weeks for OpenStack developer to add a new data source. So it can be extended to any other project or tools. The second is the notifiers. So as we just mentioned, we need to notify others about their resources, to notify them that their resources might be impacted for a failure in the hardware, for example. So we have several notifiers. We have a notifier to mark the host down in Nova. We have notifier to execute a workflow in Mistral, and so on. The dashboard we saw, we have several screens. I think we reviewed them in the demo. And last one is the templates. The Vitrage template for, this is the business logic of Vitrage, how we are raising those deduce alarms and root cause analysis. So I want to give you some example of a template. Let's take a scenario of a host iCPU load. So if you look on the diagram, we have the host, we have alarm coming from Zabbix that we have a iCPU on this host, and we have an instance. And now we're understanding the relationship between the host and the instance. We're understanding that the problem on the host will impact the instance, and therefore we are raising an alarm on the instance. And this is, the template is described this condition. In the template, you are describing that a host contains VMs and there is alarm on the host, and then what is the action? And the action is to raise the alarm. Another scenario is we have now 2 alarms, but we know that they are connected. The first alarm causes the second alarm. So we can create this relationship. So this is another one. And the last one is to set the status. In some cases, without Vitrage, you won't know the correct status, and Vitrage helps the users to understand the status. So all of these are configured by the Vitrage templates, and currently we have several use cases. It's easy to define use cases and the Vitrage templates. We have a set of out-of-the-box templates, but anyone can can define his own templates. So now it's a good time to invite Moshe to present the VNFM, the generic VNFM, and to closing the loop with the auto-healing.
Okay, hello. So at my part, I would like to elaborate a little bit about the generic VNF Manager. In our case, we are using Nokia CBAM, which is a cloud-based application manager. And on top of that, I will show you how we close the loop and how we create the framework to run auto-healing on top of the root cause analysis and on top of the failure detection. So let's start with why actually we need the application manager. So assume that you have a large operator that has to run multiple workloads among multiple VMs with large VNFs, which contain, in certain case, 20 VMs, and in another case, 400 VMs. And these VNFs need to be deployed over the cloud. So in that case, and usually what happens with the large operator is that each part of the organization need to take care for different function while deploying the VNF. So you can imagine to yourself that there is one scenario that user one need to create the cloud resources. You need, in certain case, to take a heat engine and then run and allocate the cloud resources. Then moving forward, after he allocated and created the VNF, someone need to commission the VNF. So there is another user in the organization that need to go and commission the VNF. And these two users need to speak between them and need to correlate each and every step. Now, the third part, there is also the EMS, the element manager. Once the VNF is created, instantiated, and commissioned, someone need to upload this VNF to the element manager. And this is another step that has to happen in a closed circle with the first two steps. Now, moving forward to the life cycle of the VNF, after the VNF was already created and is managed by the EMS. So in that step, imagine to yourself that there is a need for a scale operation or upgrade operation that require from the user to increase the capacity to the VNF. So again, step 1 to 3 need to happen again and again. And every time, these three users need to correlate the action between them and to speak. And the fifth action is the action that we are going to discuss in this demo, is what happens in case we have a failure. So in case we have a failure, someone needs to detect the failure, someone needs to notify the other guy that there is a failure. In a certain case, the organization will see the failure in two locations. One time in the EMS that runs the application, because the application will report about the failure. And in the second case, they will see it in the infrastructure, because the infrastructure will report the failure. So someone needs to correlate all this alarm to avoid the confusion inside the organization. And in a certain case, if the operator decides to use auto action, then it needs to give the framework to run the auto action based on the alarm detection. And that's what we are trying to do with the CBAM. We are trying to bring the framework for the user and to the operators to take all this action and to automate them into a generic VNF manager that gives the possibility to run all this action. So what are we talking about? We're talking about a software that allows you to create, to instantiate. Instantiate means to take the VNF and attach it with the cloud resources. Then after we do it and the VNF is created, we also allow to commission the VNF. We allow to register it on the EMS. Everything is done with a single step, single click. And by having a correspondence between the operators that each one of them contribute the right information to the template in order to create this operation. Then after we already manage the VNF, we are allowing to scale it. You can scale it in multi-dimension. You can scale out and in, or you can scale up or down if the vendor supports it in his VNF. We have also the healing capability. We are allowed to do upgrade. Upgrade can happen only to the application, or upgrade can create also by if you want to increase the cloud resources. And at the end, once you're already done with the application, after a few years, you can also terminate and delete the application. What we are going to focus today is the healing operation, and I will show how we are closing the loop by detecting the failure and then operating the healing operation. So how actually are we allowing to do auto action? So we said that we have the failure on the NIC, and then the Vitrage notify to CBAM about the failure in the infrastructure. But still, there is also a second stage that CBAM need to do, and this is the stage where we verify with the application that the application really wants to do this healing operation. Maybe the host failure is not affecting the application, and this is a valid scenario. So what CBAM is doing is allowing to have a framework that goes into the application, monitor relevant parameters in the application. Once these parameters reach to a certain threshold, after we monitor them, we are able, based on an analysis that we are making and based on the vendor IP, which he provides to us using a Mistral workflow. And by the way, CBAM is utilizing another OpenStack project, which is Mistral. After we analyze this information that we get from the VNF, we are able to trigger one of the lifecycle operations that we have. So the lifecycle operation, in this case, it's healing, but we can also trigger a scaling operation. So in case we are analyzing parameter at the application, and we see that we need to scale, we can also scale in a certain point. And then we can also, after we analyze it, as I said, we can execute any lifecycle operation that's available in our VNF descriptor and supported by the VNF. And this is the framework to allow the auto operation that we will demonstrate. The way that it works is that in CBAM, as I said, we have the Mistral workflow, and then we have an Ansible engine that allows us to go into the VNF and measure the relevant KPIs. So the Mistral workflow is executing a task every period of time that goes into the VNF and collect the relevant KPI and analyze them. Once we see that the threshold of the KPI is crossed, then we can run another workflow based on the decision that we are taking, and based on the Mistral capability, we can run another workflow that do the execution of the action that we want to achieve. So as I said, in this case, it's going to be healing, but on the same manner, it can be also scaling or any type of custom operation that the user wants to do. Just one last point. Obviously, that during this decision, and even if we choose to do auto operation, we can still, in this action, we can stop. We can go to the upper level, into the orchestrator, or to any tool in the network that manages the resources, and to ask approval, because before we allocate different resources. So obviously, the CBAM will not take a decision without having a proper approval, and that can happen during the process because of the fact that we are using the Mistral. So after we receive a request to scale, we can stop, we can go to the upper level, to the NVO, we can ask for the approval, and then based on that to perform the action. So what are we going to see in the demo? And in the next slide, I will go directly to the demo and cover that. So we have the VNF Manager. The VNF Manager, as Andreas showed you before, we instantiated the VNF. We update the VNF topology into the Vitrage, because up till this demo, the Vitrage knew how to show the graph up until the virtual machine. Now we added also the VNF part, and we see the all components of the VNFs, including the host, in the Vitrage graph. Then we are activating the auto action because we want the failure to be detected and handled in an auto operation. What Andreas showed you so far is just how we are detecting the failure, not how we are handling the failure with the auto action. So in my demo, I will show how we activated the auto healing. Then we will simulate a failure again. Both Vitrage and CBAM will talk with each other. One will give the information about the host failure. The other one will give the information about the VNF failure. Both of them will be synced with each other, with each information. And then after we did the correlation, we will also run the VNF healing from the VNFM to the V. In our case, the VNF healing is a simple solution to the problem that we have by evoking the VNF and creating it on a different VM. So basically, we have a host with a problem, and then we want to solve the problem, so we are evacuating the VM with the VNF to another host. And we will see in the Vitrage graph how the VNF is now connected to another host. You don't have the problem, obviously, because the problem is resolved by using another host. But the other host with the problem is still reporting the issue. Last slide before I'm going to the demo, I would like to discuss another use case, which is not related to the demo. But as I said, since the VNF Manager is sitting in the heart of the old manual setup, and we are right in the middle between the EMS, the VNF, the infrastructure, then we have another use case that we need to handle, which is not part of this demo. And this is the correlation between the application alarm to the infrastructure alarm. So in case we are getting an alarm from the infrastructure, and then the EMS, the element manager, is reporting alarm from the application, then someone needs to correlate this alarm. And this is another use case where the CBAM is getting the alarm from the infrastructure, goes up to the CBAM, and then the CBAM sends it with a REST API to the EMS. Now, the EMS see one alarm, assuming you have an application CPU, high CPU, and then you get from the infrastructure alarm another high CPU on the VM. Then you can tell the user in the EMS level why this problem is evolved. It's coming from the infrastructure, and by that it saves a lot of time for the user who see the alarm in the EMS. Now, this is an optional feature for the EMS. They can implement it by taking the alarm from the generic VNF Manager. And this is another use case, and as I said, it's not part of the demo at the moment. At the demo, we will just see how we detect the infrastructure problem, how we see it in the VNF Manager, and now we are doing the auto-healing. So we stopped here in the point where Andreas showed you how we see the root cause analysis. Now, as I said, we will go forward, and we will activate the auto operation. OK. So we are going here into the VNF Manager. Then we are going to the auto operation tab, as you will be able to see. And then after we are inside the auto operation tab, we will enable the auto operation to trigger auto healing in case of VNF failure. As I said, the VNF failure is a factor of two parameters, both failure in the infrastructure and also the fact that the VNF tells that he has a problem. Not for any problem we will create auto-healing, just if these two factors are combined together. Now we are going to the topology graph. We will simulate the failure again. We will see that the VNF and the host reports about the NIC failure, similar as Andreas showed before. And then afterwards, we will see how the VM is evacuated into a new host. So now we see the failure. We see the alarm connected to the relevant items in the topology graph, to the VNF, to the VM, and to the NIC. And then in the second step, everything is recovered and moved to the new host. So now we have this host over here, which still have the problem, because nobody recovered the NIC. But the VNF, and the VM are evacuated and migrated to another host. And now, since they are working on a host that is perfectly fine, everything is OK. Now, if we will go to the alarm view, we will see the alarms, the relevant alarms on the relevant hosts. Currently, we don't see any alarm on the application level because the application is recovered on the new host and everything is fine. And if we go to the root cause analysis screen, we also see that we have only alarms on the host and not on the application level, also on the root cause analysis. Now, just in order to close the loop and really show you that something happened in the CBAM also have an operation execution log. So we can also go to the CBAM and to see that really we perform the healing operation on the CBAM, and we will see it in the operation execution log. And we will see the exact time that the healing operation has been performed, and something indeed happened in the VNF Manager, and that's how the VM and the VNF evacuated to the new hosts. OK. So I hope that by now you managed to see how we are closing the loop between detecting the failure and actually performing a cure to the failure that we detected. Hopefully you understand that some of the operator will choose to use automatic operation, but some of them will choose not to do that, and then they can stop in what we showed in the first demo and just have the alarm detection, the root cause analysis, and then they can go to the CBAM itself at the operation screen and click on a heal operation when they decide to do that. There is obviously another option that we can do auto operation by having a manual approval. This is a third option. And that's how we suggest to close the loop. We actually see that it's very well accepted in the field because there are many operators today that are using the auto operation capability. Some of them do it based on the VNF alarms. Some of them are doing it both on the infrastructure alarms and merge it. And there are different use cases when we are utilizing the auto operation. So to sum up, there is, let's say, a complexity of managing different alarms from different aspects. Everything are separated between the physical infrastructure to the application infrastructure, and someone needs to correlate between them. The VNF Manager, which sits right on the middle between the VNF, EMS, and infrastructure, is the point that takes all the information and correlates it to the relevant parts in the instrument. What we did now is that we utilize actually 3 to 4 different OpenStack projects. When we create the VNF, we are utilizing the heat capability. When we commission the VNF, we are utilizing Ansible. When we did the root cause analysis, we utilized the Vitrage capability. And above all, there is also the Mistral, which is a workflow engine that we embedded into the CBAM. For all the parts, by the way, we are using always the upstream. So Mistral, Vitrage, always is the upstream, and we contribute to all of these projects. And we really believe that this way, to monitor all the alarms separately and then to correlate together the alarms, and based on that also to provide a framework to run auto action, is the right way to save a lot of time with monitoring and curing a VNF problem in a large organization. So with that, thanks a lot, and I believe that we still have a few minutes for a question. 1 minute. I just have to say that we are running this demo in our booth. So in any point of time, you can jump to our booth. We can run it again. We have another beautiful demo that we run over Kubernetes. And you can also ask questions at the booth. We will be there. I'm available between 3 to 5, but my colleagues are also always there. And we still have 1 minute, so if you have questions. OK, I understand that all of you want to go to lunch, so thanks a lot.